Uber NYC trip data analysis for beginners. Learn the basics of data mining with Python and Jupyter. Explore Uber trip data using real-world examples. Perform simple statistics and visualizations with pandas and seaborn. No prior experience is needed for this lesson. By the end, you will understand how to explore and plot real data sets. Running the cell now. What is data mining? Data mining means finding useful information in piles of data. We spot patterns, detect trends, and answer questions with facts. It is a big part of data science, business, and more. Python makes this process easier, faster, and more fun. We use data mining anytime we explore, clean, or visualize data. Running the cell now. Our mini-project, Uber Trips in New York. We will use real Uber trip data collected from New York City. This is a small sample, so it runs quickly even on slow laptops. You will see how to find busy hours, popular spots, and more. These skills are useful in almost any job or school project. Running the cell now. Let us set up our notebook so warnings will not distract us later. Suppressing warnings is a good habit for easier reading and teaching. This comment explains that we are hiding warnings for a cleaner look. We import the warnings library and tell it to ignore future warnings. Import numpy as np. We set the random seed to 42 for reproducibility. Running the cell now. This code sets up our environment by importing necessary libraries and suppressing warnings for a cleaner notebook experience. Although it produces no visible output, seeding the random number generator ensures reproducible results when we analyze Uber trip data later. This step helps maintain consistency as we explore busy hours and popular locations in New York. If any code triggers a warning, we will not see it in the notebook. Now we will download and load the Uber trip data. This data contains every individual Uber trip in New York City during April 2014. This line describes our data setup. We import pandas, a tool to load and manage tables of data called data frames. We provide the direct link to the sample Uber data from GitHub. We read the CSV file and save it in a variable named df. This is our data frame. We print the shape to see how many rows and columns are in our data. We preview the first 3 trips to get a sense of what each row looks like. Running the cell now. This output shows our dataset has over 564,000 Uber trips recorded in April 2014, with 4 key columns: date, time, latitude, longitude, and base, the Uber office code. The first 3 rows reveal timestamped locations for individual trips, which we'll analyze to find patterns like busy hours and popular areas. This initial look confirms we are working with rich, time-stamped spatial data, a perfect foundation for our project. If the loading step runs without errors, you now see real-world Uber data. Feel proud, you already imported your first real data set. Let us check what columns are in our Uber trips table. This helps us see what kind of questions we can ask about the data. This comment is a reminder to always check column names. We print out a list of all column names in our data frame. Running the cell now. This output shows the 4 main columns in our Uber dataset: date, time, lat, lon, and base. Notice how these columns give us the timestamp, location coordinates, and dispatch base, which are crucial for analyzing trip times and popular areas. Understanding the dataset structure is the first step before exploring busy hours and hotspots. Seeing the columns up front helps us plan what questions or charts make sense later. Sometimes columns have extra spaces, so we clean them. It is good practice to remove any spaces from column names right away. This comment explains that this step fixes any ugly column headers. For every column name, we remove spaces at the start or end. We print the fixed list to double-check our cleanup. Running the cell now. Here, we cleaned up the column names by removing any extra spaces to ensure consistent and error-free access to data. Notice the four key columns: date, time for when the trip occurred, lat and LON for the trip location, and base, which identifies the Uber base. This step prepares our data for accurate analysis in the upcoming lessons. Now column names are short and tidy. This helps us avoid errors if we type column names in later code. Exploring the data, what do these trips show? The data shows Uber pickups in New York for each trip. Each row gives us the date, the precise location, latitude and longitude, and a base code. We can learn about city patterns like when people ride and where. Before we visualize, let us make sure everything is clean and easy to use. Running the cell now. Let us check for missing values. Missing values are empty or blank spots in our data. If these exist, they can break analysis later. This comment explains that we are searching for gaps or missing entries. We use isNull and sum to count missing values in each column. Running the cell now. This output confirms that our dataset has no missing values across all key columns: date, time, latitude, longitude, and base. This means our data is complete and reliable, allowing us to confidently explore patterns in trip timing and locations without worrying about gaps or errors. Ensuring data cleanliness is a crucial step before we move on to mapping and analyzing ride trends. If columns show all zeros, there are no missing data and we are ready to work. Our trip times are stored as plain text right now. To work with dates and hours, we need them as proper date-time objects. This comment explains why we convert the date-time data. We use pandas to convert the text column to date-time type. We print the data type to check it worked. We print the first two dates to see the results. Running the cell now. This output confirms that a date-time column was successfully converted to a date-time type, which is crucial for analyzing when trips occur. Notice the clear timestamp format, allowing us to easily extract parts like hour or day for pattern analysis. This step ensures our data is clean and ready for meaningful time-based insights. With this step, we can easily group by hour, day, or week. Let us add columns that tell us the pickup hour, the weekday, and the day of the month. This way, we can spot trends over different time periods more easily. This comment shows we are making the data richer. We create a new column with just the hour from the trip time. A new column for the weekday lets us see if weekends are busier. We also add the day of the month. We preview the first three rows of these new columns. Running the cell now. This output shows the first three rows of our new time-based columns: hour, weekday, and a day, extracted from the original date-time data. Notice all pickups happen at midnight, hour 0, on the same day, day 1, and weekday 1, which is Tuesday, confirming our extraction worked correctly. These columns will help us analyze ride patterns by time and day in later steps. Now our data is ready for some cool exploration. We can learn by asking about time patterns. Time to visualize. Let us see the trends. Charts make patterns clear and easy to spot. We will use Seaborn and Matplotlib, two popular Python libraries. Let us find out which hours are busiest for Uber pickups. Running the cell now. Before plotting, we need to import some plotting tools. Matplotlib and Seaborn are the most common choices for easy, attractive graphs. This comment is a reminder that plotting code needs these imports. We import pyplot, which is the main plotting tool from Matplotlib. Seaborn makes charts look better by default and adds more features. This command uses a clean grid style for all Seaborn graphics. Running the cell now. This code sets up the plotting environment by importing Matplotlib and Seaborn, and applies Seaborn's white grid style for clean, readable charts. While there is no direct output yet, this preparation is essential for creating clear visualizations to explore Uber pickup trends by hour. Next, you'll see how these tools help reveal patterns in the data. We are all set to draw charts for our Uber pickups. Our first chart answers the question, At what hour do most Uber trips begin? We will count how many rides occur at each hour of the day and plot the results. This comment explains we are visualizing pickups per hour. We create a new chart window that is wide enough to read. We use Seaborn to count the number of rides for every hour of the day. We give the chart a clear title so viewers know what it shows. We label the horizontal axis so it is clear these are hours. We label the vertical axis as the number of trips. This line displays the finished chart in our notebook. Running the cell now. This count plot shows the distribution of Uber pickups across each hour of the day, revealing clear peaks and troughs. Notice the shape, with higher counts during typical commuting hours, which helps identify the busiest times for rides. This visualization directly supports our lesson goal to spot trends quickly using charts. What you see is a visual answer to when do people ride Uber the most. Do you notice busy times like after work or in the evening? If you are enjoying learning, do not forget to like this video or subscribe for more beginner projects. Let us see if some days are busier than others. By plotting trips grouped by the day of week, we can spot weekend or workday patterns. This comment tells our goal to see pickup patterns across weekdays. We set up a standard-sized plot. We count trips for each unique weekday using Seaborn. We add a title to explain the numbers for each day. We make it clear that 0 means Monday, 6 means Sunday. We label the vertical axis for the number of Uber rides. Display the chart in our notebook. Running the cell now. This bar chart shows the number of Uber pickups for each day of the week, with weekdays labeled from 0, Monday, to 6, Sunday. Notice how the heights of the bars reveal trends, such as which days have the highest or lowest trip counts, helping us easily identify the busiest days. This visualization makes the underlying patterns clear, fulfilling our goal of spotting trends in the data using Seaborn's count plot. A line chart helps us see how busy Uber was over each day of the month. This is called a time series plot, one of the most common tools in data mining. This comment describes that we are building a time series plot. We count the number of trips on each day of the month. We create a figure wide enough for all days. We draw a line plot with circles to show number of trips per day. Add a clear chart title for the topic and time range. Label the x-axis with days of the month. Label the y-axis so the meaning of the numbers is clear. We set custom x ticks to make it easier to read the chart. Turn on grid lines to make points stand out. Display the chart. Running the cell now. This line plot shows the total number of Uber trips for each day in April 2014, revealing clear daily fluctuations and an overall trend. Notice how the coral markers highlight each day's count, making it easy to spot peak pickup days and lulls. This visual directly supports our goal of identifying busy times by turning raw counts into observable patterns. With one line of code, you can watch ride numbers rise and fall. Maybe you notice weekends are different, you are doing real analysis. Let us see where rides happen in the city. We will plot all pickup points on a map like scatter plot, each point is one Uber ride. This comment signals we are doing a geographic plot. We make a big enough figure to look like a map. Each point shows the exact spot of a pickup. We use tiny, see-through dots for big datasets. We add a simple but clear title for context. We label the axis so you know what directions mean. Set x-axis limits to focus in on the city area for longitude. Set y-axis limits for latitude to match the map of NYC. Display the map scatter plot. Running the cell now. This scatter plot shows the geographic distribution of Uber pickups across New York City in April 2014, revealing dense clusters in key areas like Manhattan. Notice how the points concentrate around central locations, which helps us visually identify the busiest pickup spots. This visualization sets the stage for analyzing temporal trends by first understanding where pickups occur most frequently. The result is a real snapshot of city traffic from above. Can you spot the Manhattan Island shape and airport clusters? Let us quickly check the earliest, latest, and average pickup hours. Knowing these stats helps us tell the story of the data in plain English. This comment explains we are getting some quick summary statistics. We print the earliest pickup hour that appears. We print the latest hour any trip was started. We print the mean, or the typical, pickup hour. Running the cell now. This code snippet reveals that Uber pickups happen throughout the entire day, from midnight, hour 0, to 11 p.m., hour 23, with the average pickup time around 2:45 p.m. Noticing this spread helps us understand the full range of activity before we visualize, setting the stage to spot peak hours and trends clearly in the upcoming charts. You can use these numbers to summarize your findings to anyone. If the average is near evening, you might guess many people use Uber after work or for going out. Mini project: what other questions can we ask? Try plotting the number of Uber trips per base code. Check if the location spread changes by hour or weekday. For a challenge, plot pickups for just one very busy day. Pause the video and experiment. Share your findings in the comments. Running the cell now. Each Uber trip is linked to a base, which is like a hub or garage. Let us plot how many trips are linked to each base code in the data. This comment gives context on Uber base codes. Set up the bar plot to be wide enough for all base labels. We count trips assigned to each base code and plot them. Add a descriptive title to explain the chart. Label the x-axis to show what base codes are. Label the y-axis for the number of trips. Display the chart. Running the cell now. This bar plot shows the total number of Uber trips for each base code, highlighting which bases handle the most pickups. Notice the varying heights. Some bases clearly have more trips, helping us identify key locations with higher activity. This visualization ties directly to the lesson's goal of exploring data by categories to uncover patterns or differences. You can now see which bases handle more or fewer trips. Think about why some bases might be busier than others. Let us filter the data for just one base location using input. You can type in any base code you saw earlier. Try B02512 to start. This comment explains our goal, filtering for a single base. Prompt the user to type a base code. Examples include B02512 or B02598 from previous charts. We select only rows from our dataset matching the type base code. Show the shape of this filtered table to see how many trips matched. Display the first few trips for this base as a sample. Running the cell now. Here, we filtered the dataset to include only trips from the base code you entered, resulting in 35,536 rows and 7 columns. Notice the key columns like hour, weekday, and day, which help us analyze how trip locations and frequencies change over time. This step is essential for focusing your analysis on a specific base, allowing you to explore patterns more deeply in the following visualizations. Try this with another base code and notice how busy or quiet some locations are. Interactive filtering like this helps you explore any large dataset. Do not forget, playing with data is how you learn fastest. Good habits include saving your work. Let us export the filtered base data as a fresh CSV file for sharing or later use. This step explains we are saving a subset of our trips. We save our filtered data frame as a new CSV file, not including row numbers. We print a confirmation message so you know the file was written successfully. Running the cell now. This output confirms that the filtered Uber trip data has been successfully saved to a new CSV file for further analysis. This step is crucial for preserving the subset of data you've been exploring, such as trips by base code or specific dates, enabling you to easily reload and visualize it later. Saving your filtered results ensures your work is organized and ready for continued experimentation. Being able to export and share just what you need is a key skill in data mining. You can now open this file in Excel or use it for another project. Key takeaways and next steps. You loaded, cleaned, and explored a real Uber trip dataset. You learned to summarize and visualize time and place with charts. Try running the same steps on your local travel or commute data. Did you find any surprises in the patterns? Share your results below. Like and subscribe if you want more beginner data science lessons. Practice is the fastest way to master these skills. Running the cell now.